Okay, welcome to the Physics Colloquium at City College. So today's topic is slightly different from what we are used to normally, but it's a pleasure to have Dr. Zia Mian with us to talk about dismantling the nuclear doomsday machine. So Professor Zia is a co-director of the program on science and global security and co-chair of the International Panel of Fissile Materials and director of Princeton's project on peace and security in South Asia. And he has been an expert on the policy and technical aspects of nuclear arms, and he received American Physical Society's 2019 Leo Szilard Award for promoting global peace and nuclear disarmament, particularly in South Asia, through academic research, public speaking, and his organizing efforts to ban nuclear weapons. My first encounter of Professor Zia was at JNU when I saw his article with my then professor, Professor Raja Raman. So it's a nice circle to finally meet him, even though not in person, but virtually. So Professor Zia, it's a pleasure to have you, and the virtual floor is yours now.
Thank you, Sriram. Welcome, everyone. The talk that I'm giving today is part of an initiative by a new organization, the Physicists Coalition for Nuclear Threat Reduction, and which is sponsored by the American Physical Society and based at the Princeton Program on Science and Global Security. And what we're trying to do is to reach out to fellow physicists in the physics community to encourage them to have a conversation and to re-engage with issues of nuclear weapons policy, because we believe we are at a pivotal time in the decision-making in the United States and elsewhere about nuclear weapons that will have implications for many decades to come. And so we think it's especially important for the scientific community to engage with the policy issues, with the policy process, with the public on these issues. And so this is one of a series of talks that we're giving around the country. We've been speaking, I think we've reached about 60 physics departments with similar kinds of colloquia. And so let me begin by thanking you for the opportunity to have this conversation with you. And my remarks, of course, are my own. I'm not speaking on behalf of the American Physical Society. And my talk will basically have three parts. First of all, I'm going to try and explain how we got to having a nuclear doomsday machine. And then I'm going to tell you what we understand about the nuclear doomsday machine that we have, and that knowledge is incomplete. And then where it is that we see the dynamics going and the need for intervention. And then afterwards, separately, after the Q&A, there will be a separate conversation for people who are interested in learning more about the coalition and what is it that we can do as citizen scientists on these kinds of issues. So the first point is that, as some of you may know, the Bulletin of the Atomic Scientists, which was founded by some of the Manhattan Project scientists that built nuclear weapons for the United States during World War II, became so concerned about the implications of nuclear weapons after the war and the lack of understanding among policymakers and the public about what the nuclear age might mean, that they created this Bulletin of the Atomic Scientists. And it's been setting what it calls the doomsday clock, which is their judgment of how far we are from catastrophic collapse of human civilization as we know it, in part because of nuclear weapons. And in January of this year, only a couple of weeks ago, the clock was set at 100 seconds to midnight, where midnight is catastrophe. It was set at the same time a year earlier, in 2020, and this 100 seconds to midnight is the closest we have been to midnight since the early 1950s, when thermonuclear weapons were first invented, hydrogen bombs. And I'll try and explain why that is the case. So the concern about what nuclear science and technology might mean for human beings is actually almost as old as the science itself. The great English writer C.P. Snow once observed that scientists have the future in their bones. And there's certainly some element of truth in that when you look at the story of concern about nuclear weapons among the scientists who pioneered our understanding of these things. So as many of you will know, when Rutherford and Soddy first began to understand and explain radioactivity over 100 years ago, it actually didn't take long for Soddy at least to realize and make public his concern. And he gave a lecture to the Society of Engineers in London in 1903, warning that whoever could put their hand on the lever of atomic energy would possess a weapon by which they could destroy the Earth. So the potential catastrophic military use of this science, even before anybody even understood a small fraction of that science, and certainly not how to turn the science into a technology, has been there for a very long time. And similar insight came, several decades later when Leo Szilard, who, as you will know, had the idea of the fission chain reaction. Soon after coming up with the idea of a fission chain reaction, Szilard actually wrote that this meant that it would be possible to both liberate energy on a large scale and to construct atomic bombs. And he observed that there was little doubt in his mind that the world was headed for grief, in part because of the political conditions of the world in the 1930s. And so, since we're all physicists, I won't, go into the details of, fission. But the fact of the matter is that the explosive power that, runaway fission chain reactions can produce is vastly larger than that of any comparable mass of a chemical reaction. So it didn't take long for physicists to begin to turn the theory of fission and fission chain reactions into the possibility of the construction of the weapons that had been the source of concern. So while the history of radioactivity and of the lives of great physicists is well known, some of the concerns that they have were written as secret documents to governments. And so in March 1940, Otto Frisch and Rudolf Pearls, who had fled Europe as refugees, ended up at the University of Birmingham, and they wrote a secret memorandum to the British government that was classified for a long time on the possibility of the construction of a super bomb using the fission chain reaction in uranium-235. And they, from pure theory, they deduced that it would work, that uranium-235, basically pure uranium-235, would what you would need, and that would require uranium enrichment, since natural uranium is only 0.7% uranium-235. But they also were able to calculate, and the equations are there in their memo, which is now available, that a 5-kilogram bomb made from uranium-235 would be able to destroy the center of a large city because of the explosive power that would be released. And that because of the nature of the fission chain reaction, the radioactivity that would follow and the direct radiation that would follow the fissioning of the uranium-235 would produce both prompt radiation and fallout. And they wrote in their memo in 1940 that there would be radioactive fallout carried by the wind and that atomic bombs could not be used without killing large numbers of civilians. And the British government went ahead and decided to build one. Their efforts were, however, frustrated by the war. And so they passed on this information to the Americans, who then launched the Manhattan Project and were successful. But, at the same time as this is going on, Niels Bohr and Einstein and others are warning governments that you should be very careful about this, that this is a whole new era of human experience that is being opened up by these weapons. So Niels Bohr in particular was, as one of the most eminent physicists in the world at that time, had direct access to prime ministers and presidents, including Winston Churchill and President Roosevelt of the United States. And he wrote to them and met them and urged them to deal with the fact that they were building something that, was just incalculably consequential for world politics, and especially to make sure that there was no arms race that might emerge after World War II, and that they should share their work on nuclear weapons with the Soviet Union rather than risk competition after the war. And Szilard managed to work with Einstein and others and petitioned the US president, once the bomb was almost complete, to not use it, warning that, the cities of the United States and of the world would be in grave danger from this new weapon. And the petition, never actually reached President Roosevelt. But despite the efforts of the scientists both to think about and propose the possibility of nuclear weapons and to try and restrain the development and use of nuclear weapons, when it came to actual policymakers, the dynamics were very different, because they understood what was in play. And we can date this coming of nuclear knowledge at least to the leadership of the United States very precisely. So on April 25th, 1945, between noon and 12:45, the Secretary of War, what we would now call the Secretary of Defense, Henry Stimson, went to see President Truman, who had taken office after the death of President Roosevelt. And he told Truman about the secret Manhattan project to build a bomb. Truman, as Vice President of the United States, had not been told about the Manhattan Project, and neither had Congress. Truman's memo and diary notes explain what he told, what happened in that conversation. Stimson told Truman that the atomic bomb is the most terrible weapon ever known in human history, and that modern civilization might be completely destroyed. And they went ahead with continuing the bomb program. At this time, in April, the first bomb had not been assembled, it had not been tested, and it was months away from the possibility of use. The project could have been stopped, but it wasn't. So the first nuclear explosion was carried out by the United States in New Mexico. And the first victims of nuclear weapons, the first civilian victims of nuclear weapons, were actually Americans. And people have lost focus on this fact that the nuclear test in July 1945 in New Mexico, which was about 21,000 tons of equivalent chemical explosive, according to the US National Cancer Institute study as of September of last year, that test caused as many as 1,000 cancers that have already occurred or are projected from the radiation exposure from that test in 1945 to the residents of New Mexico, because they were not told that a nuclear test was about to be conducted in their area. And so there was no warning. No one was asked to take precautions because it was supposed to be a secret. And there is a large, long-standing effort by the people from that area to seek recognition and compensation for the health effects that they have endured for all of these years. The first bombs were built soon afterwards. One used highly enriched uranium as the fissile material, the other used plutonium as the fissile material, and one was used to destroy Hiroshima and the other was used to destroy Nagasaki. In both cases, about 1 kilogram of the fissile material actually underwent fission, and the yields were of the order of 15, 20 kilotons. There's a long-standing debate about why the United States had to build 2 different kinds of nuclear weapons and destroy 2 different kinds of cities. And a strong case can be made that in part this was just to see what it would do. It was scientific curiosity and military curiosity about the capability of different kinds of nuclear weapons. What did these bombs do? One of these slides shows Hiroshima, the other slide shows Nagasaki. And in one, between 70,000 and 140,000 people were killed, and the other one, between 40,000 and 70,000 people were killed. So what was learned by 1945 is that one bomb could destroy a city, killing tens of thousands, perhaps 100,000 or more people, as opposed to large air raids with hundreds of airplanes carrying thousands of bombs. So it was many orders of magnitude increase in the efficiency of the killing of cities, of strategic warfare. The physicists again sought to intervene now that the world had seen what nuclear weapons could do. And Einstein led a group of distinguished physicists. Einstein was at Princeton at that time, by the Institute for Advanced Study, in forming the Emergency Committee of the Atomic Scientists. And he wrote to physicists all over the world saying that, we have to educate people about the danger of what he called the simple facts of atomic energy and its implications, and that an informed citizenry is our only security and our only hope. In other words, the faith is not in leaders, but in the democratic process, in people expressing their concern and demanding that their governments engage and end the threat from nuclear weapons. And the Emergency Committee, launched a mass public education campaign in the United States about nuclear weapons. And it did help shift the tide of public thinking about nuclear weapons substantially. Immediately after Hiroshima and Nagasaki, opinion polling suggested overwhelming support for the destruction of the Japanese cities by US nuclear weapons. Within a few years, in part because of the efforts of physicists, public understanding of the consequences of nuclear weapons led to significant shifts in public opinion away from supporting nuclear weapons. At the same time, as Einstein and the public is being mobilized, the United Nations is coming into play. And it's worth reflecting that the very first resolution ever passed by the United Nations, Resolution 1, on the first meeting of the United Nations in January 1946, was not to deal with the consequences of the tens of millions of people killed in World War II, or the need to reconstruct Europe and other parts of the world devastated by the war, or even to establish the organizations and structures of the United Nations. The first resolution dealt with the need to deal with the problem of nuclear weapons. And it called for the establishment of a commission to deal with the problem of atomic energy, and it called for a plan for the elimination of nuclear weapons and other weapons that could be used for mass destruction. And this has been the oldest resolution of the United Nations. And it has still not been fulfilled since there are still nuclear weapons in the world. And so to kind of speed up through the Cold War period, the United States, as Niels Bohr had warned, was soon not the only country with nuclear weapons. The Soviet Union tested nuclear weapons soon afterwards. And, which led the United States to ask its scientists whether it was possible to build thermonuclear weapons, where fusion of light nuclei rather than the fission of heavy nuclei is the source of the energy release. And the scientists were organized into something called the General Advisory Committee. And they issued a secret report to the US government saying, yes, we could build thermonuclear weapons, but we should not build thermonuclear weapons. And the reasons they gave were profoundly moral and ethical reasons. And Robert Oppenheimer, Enrico Fermi, and others were part of this group. And they said that thermonuclear weapons would basically be weapons of genocide. And the only role they would have would be in a policy of exterminating civilian populations. The US government authorized the development of thermonuclear weapons. And the Soviet Union followed, as did other nuclear weapon states soon afterwards. And the first thermonuclear weapon test, Operation Mike, in 1952, was just over 10.4 megatons. So about 700 times the energy released in Hiroshima. The mushroom cloud was, as it says on the slide, 30 miles high and 100 miles wide. Again, in one last effort by Einstein and others, there was an attempt to try and warn the public. And Einstein and Bertrand Russell issued the Einstein-Russell Manifesto in 1955. And it's often forgotten now that everybody remembers Einstein as a profound physicist who shaped our understanding of nature. But it's often overlooked that Einstein was also a socialist and a pacifist, and made no secret of his political engagement as a public intellectual. And so in the Einstein-Russell Manifesto, they warned about thermonuclear weapons as a means by which we might actually end the human race, and urged humanity to remember their humanity and forget the rest. And the organization that was founded, the Pugwash conferences of science and world affairs, that brought together scientists from the United States, the Soviet Union, and around the world to think about the dangers of nuclear war and how to mitigate and end that, actually received the Nobel Peace Prize in 1995. But all of these efforts came to naught because of the sheer military interest in nuclear weapons. And because of declassification in the United States, we're beginning to get a sense of what the military understanding of nuclear weapons actually was. So in a recently published book, Daniel Ellsberg, who some will remember from his leaking of the Pentagon Papers about the Vietnam War, issued a memoir called The Doomsday Machine, where he reveals information from the time where he worked as a nuclear war analyst, strategist, and planner for the US government, including in the Kennedy White House. And on behalf of President Kennedy, Daniel Ellsberg wrote a question to the US military leadership, the Joint Chiefs of Staff, asking a simple question which had never been asked before. Between 1945 and 1961, how many people would die if the US carried out its nuclear war plan? And the answer came back as this chart, because Ellsberg redrew the chart and published it in his memoir. This was top secret from the president's eyes only. And the US military said that we anticipate our nuclear war plan as of 1961 would kill 600 million people. This is our plan. Okay? And this count did not include long-term deaths. These are only short-term deaths within a few months. And it did not include deaths in the United States from Soviet retaliation. This is only the ones that the United States would kill by launching its nuclear weapons and the consequences of those weapons in the short term. There is no comparable information on subsequent US nuclear war plans and whether this question has ever been asked again and the information made public. What we do know is that in 1961, the US nuclear arsenal was a fraction of what it was to become. So the number of nuclear weapons and the power of nuclear weapons increased after this point. It did not decrease. So in the 75 years since Hiroshima and Nagasaki, nuclear weapons have become smaller, lighter, and much more destructive. Just to give you a sense of the scale, two pictures here. One shows the first bomb, which was the one tested in New Mexico, and you can see the size of the scientist standing next to it. It was called the Gadget. It's a convenient, banal name for a nuclear weapon. And next to it, you see a modern US thermonuclear weapon, which is used as the warhead on a cruise missile, which has a variable yield, which can go from 5 kilotons, so a fraction of Hiroshima, to 150 kilotons, so basically 10 times Hiroshima, give or take. And to get from one to the other has taken an enormous research and development effort, but also has made possible huge nuclear arsenals. So the global nuclear arsenal, we have some reasonable estimates. The US actually makes public how many weapons it has now. Some other countries do, some don't. But the best estimate in the public literature is that the evolution of nuclear arsenals basically reached a peak of 70,300 nuclear weapons in 1986, just before the end of the Cold War. The Russians actually, the Soviet Union, had more nuclear weapons at that time than the United States. And arsenals have fallen significantly since then. But you can also see here just how large the arsenals of the US, Soviet Union, and Russia were compared to the other 7 countries that have nuclear weapons. China, France, India, Israel, North Korea, Pakistan, and the UK. I mean, they barely show up on the scale that is used here. And it's worth recalling that there are only 9 countries with nuclear weapons out of 193 countries in the world. And this poses a question for political science and international relations about what is it about security policy thinking and policy making that leads 9 countries to make nuclear weapons and the other countries to find other ways of dealing with security matters, since there is certainly no question that many of the other 193 countries in the world could make nuclear weapons if they put enough time and effort into it. Nuclear weapons, evolution also required nuclear weapons testing, and there have been over 2,050 nuclear explosions at over 60 locations around the world. And not surprisingly, most of them were in colonial territories or territories where people were unable to prevent nuclear testing. indigenous and poor communities. And the United States has conducted most of the nuclear tests. More than half of all the nuclear tests ever carried out have been by the United States. And almost all of those tests were actually on the land of the Western Shoshone Nation in Nevada, for which they did not give consent. The effects of all of this nuclear testing, especially the atmospheric testing, has led to radioactive fallout spreading around the world. You can actually now find traces of plutonium and other long-lived isotopes basically as a geological marker around the world. And some people have suggested that we in fact use this as the marker for the Anthropocene, the period at which the geological history of the Earth recognizes the existence of humankind as a geological force. But it's been estimated that large numbers of people, of the order of 500,000 people around the world, would actually get cancer, and a large fraction of them would die from the effects of global atmospheric testing. And in the case of the United States, the US National Cancer Institute actually estimated that there were on the order of 20,000 extra cancers and about 6,000 deaths in the US from US nuclear testing in Nevada. And they actually published a map showing radiation doses from to the thyroid from radioactive iodine distributed at the county level across the United States. And so it's now actually possible to go off and see what doses people at the time of nuclear testing were actually getting. So where are we now? There is enough highly enriched uranium and plutonium worldwide for about 240,000 simple nuclear weapons, Hiroshima, Nagasaki style weapons, which you only use one fissile material as the explosive source. We estimate through the work of our International Panel on Fissile Materials that there's about 1,860 tons of plutonium and highly enriched uranium. A fraction of it is in actual nuclear weapons, and a lot of it is in storage. About 99% of this material is held by the nuclear weapon states, mostly by Russia and the United States, but most of them have ended production, except Israel, India, Pakistan, and North Korea. And the United Nations has been seeking now for more than 20 years to agree a treaty to ban the continued production of these nuclear material for weapons purposes, but Pakistan has been blocking the start of negotiations. So in terms of nuclear arsenals today, this is the current best estimate in the public domain. So there are around 13,000 or so nuclear weapons in the world, mostly held by the United States and Russia. And then France, China, the UK, Pakistan, India have a couple of hundred each, and Israel and North Korea are believed to have less than 100 each. And the nuclear postures that declared policies of when they would use them vary. Some countries like the United States and France and Russia have policies of the first use of nuclear weapons, where they would start nuclear war under some circumstances. Others, such as China and India, have a position that they would not start a nuclear war, but they would retaliate if they were attacked by nuclear weapons. We also know that there have been a significant number of nuclear weapons accidents around the world. Declassification in the United States has helped cast a useful light on these processes, and there is not similar information available in other countries where this information is held more tightly. But we know, for example, of cases where nuclear weapons being transported across the United States actually fell off the airplanes they were carried on and almost detonated. And in some cases, it was because the system that was supposed to prevent detonation didn't work. So in other words, it was a double accident. We've also seen cases of nuclear weapons actually being mistakenly loaded on airplanes and flown across the country. And for more than a day, 6 nuclear weapons as of 2007 were actually in the wrong place because they'd been put on an airplane, flown across the country, and no one knew that they had left one US airbase and arrived at another airbase, and they just sat there. And there was one recent incident in 2010 where 50 nuclear missiles in silos in the United States, in Wyoming, the command officers actually lost control of them altogether. They couldn't contact them at all. And now you can actually see markers, historical markers, where some of these nuclear accidents happened in the past. There also have been false alarms of nuclear attacks, which raises grave concerns about the process of actually managing nuclear weapons in a real crisis. So the US uses satellites and radars to detect the launch of nuclear weapons directed at the United States. And in the past, US radars have seen dozens of what were Soviet missiles coming towards the United States, and it was actually a false alarm. There have also been false alarms due to software and hardware failures. And similarly, there have been instances that we now understand of Soviet satellites mistaking other signals for the launch of US missiles, including the sun being reflected from clouds. And now there is grave concern about whether uncertainties about hacking and other things will add to new sources of false alarms and concern. This has a special significance in the United States and other countries where weapons are kept on high alert, ready to launch, because that means then that decision makers only have of the order of 10 minutes or so to make a decision in response to an alarm that the country is under attack as to how to respond. And so there is a lot of concern about false warning leading to a mistaken launch of nuclear weapons and the start of nuclear war. One other thing that we've discovered about nuclear weapons is that for a long time, we underestimated the effect of nuclear weapons systematically, because many nuclear weapon tests were actually done in empty places, right? Either in the atmosphere, in the ocean, or in holes in the ground. And nobody actually dropped nuclear weapons on modern nuclear weapons on cities to see what would happen, unlike the destruction of Hiroshima and Nagasaki. And physicists have started to understand that modern thermonuclear weapons produce much greater fire effects in urban areas than military planners and nuclear tests had revealed in the past. And so modeling these fire effects suggests that modern thermonuclear weapons are actually far more destructive than anybody had anticipated. And this graphic tries to show the scale of that. So the yellow circle and the orange circle in the middle shows the Hiroshima-sized explosion, and then the orange circle in the middle shows the explosion from a 200 kiloton thermonuclear weapon. And the area destroyed by the explosive shock wave is far larger than that of Hiroshima, but the fire effect is very much larger. So it turns out that thermonuclear weapons are in fact firebombs. And we weren't able to see this because of the nature of the nuclear tests, because there wasn't anything to burn where these weapons were being tested. And Lynn Eden, who's a sociologist of nuclear institutions, in a fascinating book called Whole World on Fire, actually tracked down why the US military, the nuclear military planners, even though they know this information, don't include it in their estimates of nuclear war effects. And the answer is that the US military thinks fire is unpredictable and uncertain, and so they won't include it in their estimate of how big a weapon you need to destroy how large an area and what kind of target. So all existing, as far as we know, US estimates of nuclear war consequences, which are classified to the extent that they don't include the effect of fire, are a gross estimate. So independent scientists have tried to think about the effects of fire. And one example is recent work done by Alan Roebuck and his collaborators, where they looked at using nuclear weapons by Pakistan and India against each other, where they looked at using 50 weapons of Hiroshima size. And they looked at just the fire effects from those relatively small weapons. And they showed, using atmospheric transport and climate change models, that within a couple of months, the smoke from these burning cities would basically cover the Earth. And the model suggests that the restriction on sunlight reaching the Earth because of the smoke and the soot in the atmosphere would last for about 25 years. And it would be sufficient that the surface temperatures would drop and ozone would be destroyed, causing potentially catastrophic famine for large parts of the world. And this is with 100 nuclear weapons. If you look at where nuclear weapons, of the level of the use of nuclear weapons in a war between the United States and Russia, for example, which are the largest nuclear weapon states, with their current nuclear arsenals, the change in temperature and precipitation would be sufficient that we would be pushed into a climate threshold that would be colder than the last ice age, which means that basically all of modern civilization would be catastrophically disrupted. So in 2020, the US Congress wrote into law a requirement that the National Academy of Sciences conduct a study, which will begin this year, on the environmental effects of nuclear war. And there will be both a classified and an unclassified version of this assessment. So we'll begin to see how these kinds of analyses hold up. The last time that they were studied was back in the 1980s, before modern climate change models. And to wrap up in terms of the future, at the same time as we have seen a greater understanding of the effects of nuclear weapons and a stalling of the effect of the arms control process, existing nuclear treaties that emerged in the Cold War to try and limit arms racing and the risk of nuclear war have begun to erode and collapse. So one of the foundational treaties of the Cold War was the Anti-Ballistic Missile Treaty, signed by the United States and the Soviet Union in 1972, with the simple logic that if I build a ballistic missile defense system, you will build more ballistic missiles and nuclear weapons to overwhelm my defenses. And so rather than just have a cycle of ever-increasing numbers of missiles and weapons and anti-ballistic missile systems, it would be better to do without the missiles defenses. The US withdrew in 2002, and Russia uses this withdrawal as a publicly stated reason for the development of its new generation of nuclear missiles, to overwhelm the US deployment of missile defenses that has been underway in the last 2 decades. Another Cold War treaty, the INF Treaty, which removed intermediate range nuclear weapons from Europe, thousands of them, the US withdrew in 2019, claiming that the Cold War era was past and therefore this treaty was no longer relevant. And it restricted the United States in its competition against China, since China has intermediate range nuclear weapons, even though those nuclear weapons cannot reach the United States. Another treaty, the Open Skies Treaty, which allowed the United States, European countries, the Soviet Union, Russia, to fly unarmed airplanes equipped with sensors over each other's territory to look at military activities to make sure that there was no secret invasion that was being prepared. The US withdrew last year. And one of the last most important treaties from the Cold War experience, the Comprehensive Test Ban Treaty banning all nuclear weapon tests, it was actually not prepared and signed until after the Cold War. The US signed in 1996, but the US Senate has refused to ratify it. And we now know that in 2020, in the Trump White House, the White House considered the resumption of US nuclear weapon testing. And in the budget for 2020, there was money put in for the resumption of nuclear weapon testing by the Senate, but not by the House. And eventually, on a party line vote, Democrats voting against funding, Republicans voting for funding, eventually the decision was made to withdraw the funding amendments. So the only arms control treaty that is in force on nuclear weapons with any significance is now the New START Treaty, which was signed under the Obama administration, which limits the United States and Russia to 1,550 deployed strategic nuclear weapons. It does not limit how many weapons they can have that are not actively deployed. And most US and Russian weapons are actually now on reserve and in storage, or awaiting dismantlement, but not actually dismantled. And this was renewed on 29th January by President Biden and by the Russian government for 5 years. The Trump administration had delayed a decision about renewal. And so we have this restraint in place for the next few years. At the same time, we are, as I mentioned at the beginning, at the cusp of a profound moment where the United States and the other nuclear weapon states are all committing to a massive long-term modernization of all of their nuclear forces. The US plan is to spend over $1.5 trillion over the next 30 years on a new generation of nuclear warheads, nuclear missiles, bombers to carry nuclear bombs, and submarines to carry nuclear missiles. It will basically replace the entire existing US nuclear arsenal and key parts of the nuclear production complex. The first contracts for this have already been signed. $13 billion was budgeted and the contract signed for the engineering development of new missiles that will be based in the Midwestern states in silos, the Intercontinental Ballistic Missile Force. And to just give you a ballpark figure, each new nuclear submarine in the US has more than 10 of them on active patrol at any time. Each submarine costs $8.5 billion. And each new nuclear warhead, and there are thousands of US warheads in the stockpile, will cost between 15 and 20 million, according to the Congressional Budget Office. And this is assuming the arsenal stays as it is in terms of 1-for-1 and is not expanded. If some kinds of foreseeable expansions of the arsenal above the size it has today would add hundreds of billions of dollars to this cost. I'll skip that slide. So the good news of all of this is that at the same time as the US and the other 8 nuclear weapon states are moving away from arms control and modernizing their nuclear weapons, the rest of the world is pushing in a different direction. In January 2021, the United Nations Treaty on the Prohibition of Nuclear Weapons entered into force. It was negotiated in 2017, and the text was supported by 122 countries. This treaty was negotiated under UN rules with the United Nations negotiating mandate. It obliges countries to not under any circumstances, the treaty says under any circumstances, to develop, test, produce, manufacture, acquire, or possess nuclear weapons. Countries are forbidden even to use or even threaten to use nuclear weapons. This treaty forbids the practice and policy of nuclear deterrence. And it also forbids the stationing of nuclear weapons from some other country or new territory. And any country with nuclear weapons that chooses to join the treaty must remove its nuclear weapons and destroy them and eliminate the program and the facilities through a verifiable plan. None of the 9 countries with nuclear weapons today participated in the negotiation of this treaty, and all of them are opposed. And the United States publicly has called for the countries that have signed this treaty to unsign it. US public opinion, however, is on the side of the prohibitionists on this matter. A poll from just last year found that there is more than majority support, more than 50% of people in the United States, whether they're Republicans or Democrats or independents, believe that no country should be allowed to have nuclear weapons. And this continues a long-standing finding that goes back more than 10 years that find that most people in the United States support the idea that no country should have nuclear weapons, which would be the goal and is the express goal of the new treaty on the prohibition of nuclear weapons. So what we see, in fact, is that there is a gap between the international community, which has a treaty on the prohibition of nuclear weapons, public opinion in the United States and some other countries that nobody should have nuclear weapons, and nuclear weapons complexes and decision makers, which are committing to the continuation of nuclear weapons for 50 or 60 more years. And this brings me to my last slide, which is the coalition, the Physicists Coalition for Nuclear Threat Reduction, because we are motivated by the sense that we do need to intervene in the process that is unfolding at this time, given the consequential nature of the decisions and the dangers that are at work. So there is already efforts within the Congress to cut the nuclear weapon budget for the United States and stop this runaway modernization, to limit the US policy for the first use of nuclear weapons, and in fact to move to a policy where the United States, like China, would commit not to be the first to use nuclear weapons, to take away the sole authority of the President of the United States to launch nuclear weapons without consultation with anyone else, not to launch on the warning of a possible attack, but actually to wait and see whether actually there has been an attack, and certainly that there should be no new generation of intercontinental ballistic missiles. There are also initiatives at state level with state resolutions in California, Oregon, and New Jersey, where I am, calling on the US government on behalf of the people of those states to restrain US nuclear planning and forces and budgets, and to support the new treaty on the prohibition of nuclear weapons. And 37 US cities so far have passed citywide resolutions about the grave threat of nuclear weapons and expressed support for the treaty on the prohibition of nuclear weapons. And so this is what the Physicists Coalition is trying to do. We're trying to educate physicists, the public, and Congress on these dangers and ideas and possibilities, and to support initiatives in Congress to reduce the risk of nuclear weapons use, because we believe that citizen engagement and the scientific community as citizens and as informed citizens can help bring collective pressure to reduce the nuclear threat. We also seek to help develop a next generation of physicists willing and interested in engaging with nuclear policy debates, because nuclear weapons are going to be around for a long time. Nuclear weapons complexes are deeply entrenched in politics and local economies. And we're going to have to be in this struggle for a long time, and we're going to need all the help that we can get. And so with that, I will end my remarks and welcome your questions.
Thanks a lot, Zia, for this wonderful and kind of a jarring reminder of what kind of grave threat we are in. And now I think we can open for questions. So anybody has questions for Dr. Zia? Okay, I can start with a question. So the Physicist Coalition that you mentioned, so the idea is to kind of the kind of things that you were mentioning before the talk, like establish some kind of a scientific argument for kind of bringing out the facts associated with the nuclear threat, what has been happened in the past, kind of revealing the buried truths. So does that so all these things kind of, what is the body that you are trying to appeal to in the sense with all these? Because this is kind of an international problem, right? So there is no international justice system, so to say. So the countries are kind of disconnected. So how do you legislate all these issues at an international level?
Well, thank you for that question. Right now, I mean, we were founded, the coalition, founded last year, and our first goal is to develop a conversation among the US physics community to try and encourage them to re-engage with this set of issues, because the evidence we have suggests that many physicists in our community stopped paying attention to nuclear weapons issues, as did most of the public for a long time. And so people, many of the things I say are known to nuclear policy experts, but not to most physicists or most lawyers or most doctors, most politicians, and certainly not most members of the public. And so our first sense of responsibility as physicists was to reach out to our fellow physicists and say, this is what we see as going on, and this is something that I think that as physicists we can educate ourselves about and then speak up about. So it's not that we're asking people to go off and give up doing the physics that they do and all shift their focus of research and work to nuclear policy issues. I mean, there are people who do that for a living, like myself. But what we do want is for physicists to start to pay attention again to nuclear policy issues, to engage in the debate. And so as you know, one of the things that we do, for example, is that we ask members of our coalition of physicists who come to our talks and decide that they do want to learn more. We produce policy papers for them, explaining in more detail some of the things I've talked about. And then we propose actions that they can take, which are coordinated by the American Physical Society, including directly reaching out to their local members of Congress. So we've been talking at universities across the United States, and we ask people, for example, on the nuclear weapon testing issue that I mentioned, where during the Trump administration, the White House was considering the resumption of nuclear testing, and Congress was debating funding the first nuclear test in several decades. We asked the members of the coalition to contact their member of Congress to explain the dangers of nuclear testing and to urge them not to support such funding for a nuclear test. And many of them took this idea and actually did contact their member of Congress. And Charlotte Selton, who is here from the American Physical Society, in the discussion about the coalition and its work, she can tell you more about that kind of advocacy work that we do. We also, reached out to, asked people to reach out to their members of Congress on the extension of the last remaining arms control treaty between the United States and Russia and New START. And so we asked people to advocate to their members of Congress with regard to supporting the extension. So right now, what we're asking is for physicists to pay attention, to try and educate themselves, to become involved in the debate, to be citizen scientists, and to exercise their democratic rights and privileges to be able to reach out to their elected officials and others, and to the public, to work with their local peace groups and others, to say, look, this is important, and this is how I understand what's going on, and this is what I think makes sense for us to do. And we're hoping that as the coalition grows, we're still not even 1 year old, that there will be some universities where there are enough members of our coalition to support campus-based chapters. So perhaps people can find like-minded colleagues and perhaps begin a small group that will work together to learn more about the issue, perhaps think about developing a course that they might want to teach, or perhaps find ways of reaching out to other constituencies and other colleagues and other networks to engage them on this kind of issue. So we have also spoken to physics societies in other countries yet, but I think first of all, we need to be able to try and do as much as we can with regard to the community that we have most access to, which is the US physics community and neighboring science communities. So we're not all only going to speak with physicists, we're also talking to nuclear engineers and other scientists who are willing to engage with us. But the goal is to bring scientists as citizen scientists back into the debate and as a visible voice on nuclear policy debates and issues, just as there are doctors that speak up and others that they're not all, but they are there, and to show that they care and are involved. But Charlotte can explain more when we do the advocacy part of the conversation.
So there is a question by Michael. Michael, do you want to ask it? You're muted. Michael, you're muted.
Yep.
Yeah.
Very interesting presentation. I have a couple of cautionary notes. Number one, let me begin with a very short story about how CTBT collapsed in terms of the Senate. I was involved with putting together a group of Nobel laureates who supported CTBT. And unfortunately, my absence in Washington at the APS office, somehow or other, that list leaked to the Clinton administration. And this was at a time when the White House was in negotiations with Senator Domenici, late Senator Domenici in the Senate. And remember, this was October of 1996, with the election coming up just a few weeks later. And the White House was going to go ahead with an event bringing Nobel laureates together. And Senator Domenici just blew his stack. He called me, said, "What the hell is going on here?" I had gotten in touch with the President's science advisor. We tried to stop the Clinton administration from doing the event. Unfortunately, that failed. And as a result, Domenici, who actually supported the treaty, said, if I can't trust the White House, I can't put myself in the position of supporting this thing any longer. That's how it collapsed. Now, what is my point? My point is that anytime you get involved with any of these issues, there are political minefields.
Mhm.
And most physicists are notoriously ignorant of politics. And unless they are really trained in what they need to watch out for, they can do damage. And so while I applaud your efforts in trying to get the physics community more knowledgeable about this and to support the activities, I think it's extremely important that there be at least an education campaign to point out where the pitfalls are. The last point I would make is that we know from polling of the public on scientific issues generally that when Washington is involved with anything, the public trust goes way down. Therefore, for something like this to succeed, it has to be done on local levels. And that's where I think your suggestion that individual universities become involved is absolutely critical, because if this appears to be a group of elite scientists in Washington pushing something, it will go nowhere. The public will simply, at least part of the public, at least a significant fraction, will simply reject it as something they don't want to hear about and don't believe in. So that's my suggestion.
No, thank you. I mean, that's very important. We do, and the story about the test ban, and have you written this somewhere? I mean,
No, I was involved with the whole thing, but I have never written it up.
Yeah, that's a very interesting story. So thank you for sharing that. I will say that when the treaty did come up for ratification, it ended up as you will know, a party line vote in the Senate, and which was therefore insufficient at that time to get ratification. But we do see absolutely the value of beginning locally and working from the ground. And we are, learning from the American Physical Society's Office of Government Affairs, which is where our organizer, Charlotte Sutton, actually sits, to help us understand exactly these political minefields, as you say. And we also have a small group of Washington policy cognoscenti, so to speak, from the Arms Control Association and others who follow the micro details of the ins and outs of congressional politics, who have agreed to be available to us to help us better understand some of these minefields. So absolutely, it's very important, and thank you for that. And the idea of building the local chapters, we're just in the process of beginning to put that into operation. And so we're hopeful that there will be enough colleagues in different campuses to begin again. And we also see that as very important, especially if senior faculty take some leadership as a way to encourage junior faculty, postdocs, and graduate students, that this is something that you can devote a little bit of your time to in a constructive way, to lay the basis for continuity. Otherwise, it's going to be, people who grew up in the Cold War. And, we can't be around long enough. Our lifetimes are short compared to the lifetimes of bureaucracies and nuclear weapon systems. And so we do need to find mechanisms for being able to get young people to think about and engage with this issue and be willing to try and take it forward.
Let me add one more point regarding universities, and this is based upon some fairly recent polling. The public does not view the Ivy League universities or MITs, Stanford's, as that a large fraction of the public, I won't say all, but a significant fraction of the public does not trust those institutions. And they trust the state universities or the public universities much more. And I think that you can understand why. So another piece of advice is that when you focus on trying to build this out in universities, think a lot about the public universities as a fertile ground for this, because that will engender much greater public support.
Oh, yeah, thank you for that insight also. And if you could direct me to where this polling is that you mentioned, that would also be very helpful, because I think I'd like to pass this on to my colleagues in the leadership of the coalition and help us think about, the focusing.
I can probably send you a couple of slides if I can get your email. This was done by Science Counts, which I helped found about 7 years ago, and testing public sentiments on scientific issues. And this is one of the things that came out.
Great, thank you. I'll make sure to send my email on to you.
Yeah.
And Gustavo, go ahead.
So nowadays we've seen this wave of negationism. You see climate change deniers, we see anti-vaxxers. How prepared are we for a massive propaganda of misinformation? People may try to say that, this nuclear winter will decrease the temperature. This is going to be good for global warming and things like that. So there's a lot of unpacking in terms of social media and misinformation. And how much can we do? Because the more we try to present data, the worse it is.
I'm not sure that I would agree that the more that we present data, the worse it is. I think that's not a conclusion that I think necessarily follows from what you quite rightly identify as trends in social media and public opinion to some extent. But at the same time, I would urge you to think about the fact that despite anti-vaxxers and climate change deniers, as far as I'm able to judge, and others may know better, what information we do have about public sentiment suggests that there is actually significantly large, if not overwhelming majority support, but beyond, a minority who does believe that climate change poses a grave threat that does need a personal and collective action to engage. And similarly, I think that despite efforts by anti-vaxxers, people are actively seeking vaccination against COVID. And so, I think that is true for a majority of people. So certainly there will be a determined vocal minority. And in the case of nuclear weapons, we know that there are entrenched institutions who see their future tied to the continued existence of nuclear weapons. I mean, when President Eisenhower warned about the military-industrial complex, the nuclear complex was part of that military-industrial complex. And the many billions of dollars that will go to large military contractors, and one has to be honest, that will create jobs for lots of people in many places across the United States. For them, nuclear weapons will put food on the table and put their kids through college. And so we're going to have to deal with that. But I think that it's the same way that we have to deal with issues about coal mining in communities, in the debates about climate change. We put people in the position where we said that here's a job making a weapon of mass destruction, and it pays a good salary. And you should take it because your country wants you to have it, right? In the same way that coal mining communities were given jobs and said, this is going to power the country and light everybody's homes. And so we have to meet our responsibilities to these communities to provide them with fair and honest and just and equitable alternatives that do recognize that the country put them in that situation and kept them in that situation. And so that's just part of the larger issues that have to be dealt with. And I think you're quite right to point this out, but that just means that the problem is significant and has many dimensions, not just the narrowly technical and legal ones that some people see it as.
I have a question.
Yeah, go ahead.
Back in the early 1960s, there was a scientist committee for radiation information led by Barry Commoner and Margaret Mead. I knew the one in New Haven. I was a grad student at that time in the early 60s. And we did manage to talk to a fairly wide group of people. We got an article in the New Haven Register, which was a conservative paper, and so on. A lot of people did not get the point, and I'm not sure that we got a whole lot of feedback, but it's the basic idea that we tried to push was that we were giving objective scientific information, which was fairly easy because there had been a congressional hearing which assigned 3 megatons to New Haven, and obviously nobody in the state of Connecticut was going to survive. So the information that we had, while it was objective, was pretty devastating, and some people got the idea. I don't know whether some sort of more general collection of let's say a modernized scientists committee for radiation information would do a whole lot, but it had at least some effect, I believe. Any comment?
No, and thank you, because I am reminded of the fact that it was, not too, at a not too different time that Bernard Lown and others founded the Physicians for Social Responsibility, who did the first medical assessments of the consequences of nuclear war on various cities. And as some of you may have seen, Dr. Lown just passed away. His obituary was in the newspaper today. And the organization that he helped build, both Physicians for Social Responsibility and then the International Physicians for the Prevention of Nuclear War, which went on to win the Nobel Peace Prize for its work by organizing doctors to provide information to the public about what nuclear war would look like on your city and how limited medical abilities existed to actually engage or provide any relief in those kinds of circumstances. So that kind of locally rooted, ground up, professionally legitimated intervention, both by scientists and doctors, has a very important history in this field. And I think that one thing that we can say now, though, coming back to the earlier point, is that the availability of easy forms of access to large amounts of information, which we have now through the internet and so on, which wasn't around that time, means that we have to find different ways of making that information available to people. But at the same time, as Michael was pointing out, who the public sees as credible as a voice is often still locally rooted. And so we have to find a way of combining these two kinds of tendencies. And so, as I said, right now, the Physicists Coalition is still trying to gather membership and build pardon the phrase, a critical mass, and to begin to think about how to build these local chapters. And then certainly the goal is to think about public education and how to prepare the kind of materials that, larger body of citizens can have access to and can engage with and can leverage into their own ways of reaching out to elected officials and other community organizations to articulate what the public as citizens actually want, and try and use the democratic process to move that agenda forward. So, so thank you for reminding us of the importance of that kind of outreach directly to the public in a way that they can use and have access to.
So I have one question regarding nuclear reactors and their use as powering the cities and all that. So would you have similar, would you consider nuclear reactors in use of power generation as a similar threat, or you would separate them from your nuclear weapons part? Because there has been a lot of nuclear accidents, and some of them I'm sure are waiting to happen. As you mentioned, even the weapons technology was stranded somewhere without notice. So with the sustained use of a nuclear plant, maybe the accidents, the possibility of an accidents are even more likely. So what is your take on that?
Yeah, so thank you for that. So the Physicists Coalition is focused on the threat from actually existing nuclear weapons. So we've not engaged so far specifically with the threat of, for example, proliferation of other future possible nuclear weapon states. We're dealing so far with what we believe is the underappreciated engagement of the threat from actually existing here and now nuclear weapons, rather than possible nuclear weapons at some time in the future. And so we've also not engaged with this question of the risks from other kinds of nuclear technologies, including the civilian use of nuclear power, because right now we think that we have many issues that are in play at one time, and our initiative at least is focused on the threat, as I said, from actually existing nuclear weapons and nuclear weapon policies. And we focus, by and large, and I believe rightly so, on US nuclear weapons and US nuclear policy, because that's where we can have the greatest impact. We don't have access to, the public or physicists in China or North Korea or India in the same way that we have access to them in the United States or to their decision-making processes. So our approach to our work is to focus on what we see as the gravest threat, which is the threat of nuclear war, and to focus on where it is that we can have the greatest engagement, which is to other people in the US physics and scientific community and to the US policymaking process at this stage, and hope that by example and effort, and to the extent to which we succeed, we will encourage other scientific communities in the United States and others in other countries to follow and find their own path to similar kinds of engagement. And there is some encouraging news. Physics communities from a couple of other countries have already noticed what we've been doing and reached out and asked to talk to us. And so, to the extent to which we're able to succeed and develop models for how this kind of work can be done with some degree of effect, then we can perhaps encourage others to find the ways that will work for them in their own particular political setting.
Mm. Right. So, do we have any more questions? Actually, before we close the session, what would be useful is that I think Charlotte has already posted a link in the chat for joining the Physics Coalition for Nuclear Threat Reduction. So my question is that if you kind of join, it's like a registration, and so would you be able to get links to the programs and other things that you will be organizing through that, or are there resources that you can share with us where we can kind of further get educated, or more opportunities to get educated should people are interested in learning more about it?
So with that, let me hand it over to Charlotte, and she can explain a little bit more about the coalition and the kind of what's involved in joining. And so please, Charlotte.
All right. So my name's Charlotte Felton, and I'm the organizer for the Physicists Coalition for Nuclear Threat Reduction. And I just dropped the link to our website in the chat, because that's also a place where you can get more information about who we are. But I'm just going to take a minute to give you some background information about who this coalition is and what we're doing. And then I think that Zia and I will be happy to take any questions you might have. So as Zia explained, the Physicists Coalition for Nuclear Threat Reduction really has two joint goals, and that's to educate and engage a coalition of physical scientists to advocate public policy that's going to reduce the nuclear threat, just like scientists did in the 20th century, building on their legacy. So this is a joint effort between the American Physical Society, the Carnegie Corporation, and Princeton's Program on Science and Global Security. Currently, it's funded by an APS Innovation Fund grant. And just to give you a sense of how competitive that grant is, in its first year, it received 100 proposals, and this was one of just 4 projects that was funded. So APS is really taking this project very seriously and giving it its full support. However, although the name and the fact that APS is backing it makes it seem like this is a physicist-only coalition, that's not true. We are open to physical scientists broadly and include engineers, climatologists, Anyone who identifies as a physical scientist is invited to join us. And also, we have members from all career stages, from undergraduate to many years retired. And you don't have to be a US citizen. You just need to be resident in the US if you want to participate in our advocacy efforts. So I'm based in the APS Office of Government Affairs, which is the policy lobbying and advocacy arm for APS. And we're really trying to support the physicists and engineers that are leading this coalition on the advocacy side of our goals. So also from this office working on the project is Francis Slakey, APS's Chief External Affairs Officer, Kelly Pruitt, the Senior Strategist for Grassroots Advocacy, and Mark Elsesser, the Interim Director of the APS Office of Government Affairs. So we really have two main strategies that we use to impact policy. We do use traditional lobbying techniques. We have lobbyists on our staff who have relationships with policymakers and staffers on Capitol Hill. But the bulk of our efforts and the bulk of this coalition's advocacy efforts are in grassroots initiatives. And that's because we've seen from polling of members of Congress that it's interactions with constituents that are actually some of the most effective ways to shift their policy priorities. So our goal is really to help facilitate your contacts with your elected officials and help you make your voices heard. So some of the ways that we do that are letter writing campaigns, in-state and district meetings, and we can also help reach a broader public, for example, by writing op-eds for local papers. And I also do want to take a moment to point out that your senator, Senator Gillibrand, sits on the Senate Armed Services Committee, which is the committee that decides lots of nuclear policy questions. So your voices are actually particularly impactful in this policy arena just by virtue of who represents you. So I dropped the link in the chat earlier where you can join the coalition, but I'm going to drop it again in case it got buried. And I'm also going to put my email address in there. And I really welcome any of you to reach out to me with any questions you might have, but you can also ask Zia and I questions right now.
So are there any questions? I think we had some questions and people will, I think, try to look at the material and maybe reach out if they are, once they digest the information, because this is not something people are thinking normally, but it will take some time for people to process it, because I think Dr. Zia did a wonderful job of reminding us of such a grave danger these positions are in. And I think it seems that we can get into some kind of a collective boredom against these topics, but it's always good to get a reminder and kind of wake us out of a slumber that we all often get into. So, so one thing is that Professor Dr. Zia was mentioning about this program that they organize every summer at Princeton. So if you can, means some kind of an event where they can educate themselves further. So will that be automatically available if you are joining using one of these links?
No, the program that I mentioned at Princeton with regard to South Asia is only for scientists based in South Asia.
I see. Okay.
Because of the difficulties of physicists from Pakistan and India actually being able to travel and work with each other over an extended period because of visa restrictions and so on. And so Princeton offered a place where they could all come to spend time together to engage.
I see. Okay.
But if,
are there similar events where people can learn further if they are interested in? Because I think I looked at the form briefly. So the form kind of provides what people are willing to commit to. There are a bunch of things that, but I think if there are some further material that they can understand and before they can commit to certain responsibilities, I think that would be something that would be useful.
Well, I firstly want to reassure people that you're not committing to take any of the actions on the survey. We just want to get a sense of what you might be comfortable with. But when you join the Physicists Coalition, that means that we will reach out to you both with opportunities to get educated. For example, we've had now 2 webinars. Zia was actually on our most recent webinar, which was introducing some possible policy measures that the US might pursue to reduce the nuclear threat under the new Congress and the new Biden administration. But it also means that I will reach out to you with advocacy opportunities, everything ranging from sending a pre-written letter about an upcoming bill to your member of Congress with just a click of a button, to perhaps asking if you would have the bandwidth and interest to take a meeting with a staffer from your senator. So those are the sorts of opportunities that we send to our members.
Okay, yeah, sounds good. Yeah, so I will share these links through the same place where the colloquium has been advertised, and people will be able to take a look at it. And I think around 5:30 there are some classes that people may start. So I think so we can. And thanks again for this wonderful talk. And
thank you for the opportunity to have this discussion with you.
Yeah, thanks a lot. And we'll definitely send out these information through our place where the colloquium was announced. And once I post this video, I will definitely send Charlotte the link and you also the link associated with it.
So let me just add 1 second before we go, is that we do support a fellowship program for next generation young scientists, where we give them opportunities to work with nuclear weapon policy experts and to learn to get sustained training in advocacy and communication and organizing and engagement, and also to work on writing a small policy article that can be published as a way to gain some experience in how to communicate in this field. And all that information is available on the website that Charlotte sent the link to. And we're looking especially to expand the participation of women and young scientists of color in our community. And so the goal is that, as many people as possible, especially those who've been underrepresented in the nuclear field and can bring new perspectives and new energy, should be encouraged to join. And so all of that information is there. And we have 4 fellows right now, and they range from graduate students through postdocs to even an assistant professor. So, it's not limited. There just needs to be a willingness to give a little bit of time to, along with doing your physics, to learn some more and be an active participant. But all that information is available on the
Okay, great. That's fantastic then. Okay, thanks a lot again for giving this wonderful colloquium, and hope to see you soon.
Yep. Thank you.
Yeah, bye. Thanks, Charlotte. Thanks, Leah. Bye.